Question number 3, where I'm going to study a polynomial function. The first thing I'm going to do is to find the leading term, an times x exponent n. And to do so, I'm going to take each one of those 1, 2, 3, 4 factors from which I'm going to take just the leading term. So here, for this factor, I just have 1 over 10. For this one, I've got x exponent 2. So it's x exponent 1 exponent 2. Here, I would have the leading term 3x exponent 1 exponent 1. So I have 3x to the first 1. And finally, I would have x exponent 1 exponent 2. You can eventually calculate first the coefficients. So I'll have 110, 1, 3, and 1. So I'll have 1 over 10 exponent 1 times 1 exponent 2 times 3 exponent 1 times 1 exponent 2. Of course, a bunch of those, like this one and that one, you could skip, but that way you will be aware of the method to employ when it is not that easy. Then I'm going to take each of those x's. I'll have x exponent 1 times 2 times x exponent 1 times 1 times x exponent 1 times 2. So I'll end up having 3 over 10 times x to the 5th. It is enough for me to conclude the end behavior to the left towards the negative infinity and to the right towards the positive infinity. So refer to the little chart that I have, but an, which is 3 over 10, is positive, and n, which is the degree, is odd, 5. So I can directly conclude that the behavior to the left towards the negative infinity of g of x is negative infinity, and to the right towards the positive infinity is positive infinity. To find the intercept, I'm first going to get the y-intercept. Here I just need to evaluate, to plug g of 0, that is to plug in 0 in the formula. I will have 1 over 10 times 0 minus 1 square times 3 times 0 plus 2 times 0 plus 3 square, and I would get 9 over 5. For the x-intercept, here I need to solve, not just evaluate. I need to solve g of x equals 0. Now, in that particular case, I'm lucky because what is given to me is the factored form. So g of x equals 0 means that either either one of these factors is 0. Now, I can left out 1 over 10, which cannot be equal to 0, but x minus 1, 3x plus 2, and x plus 3 can. So g of x equals 0 is equivalent to x minus 1 equals 0, or 3x plus 2 equals 0, or x plus 3 equals 0. And I can conclude that it's x equals 1 or x equals negative 2 over 3 or x equals negative 3. So to give the multiplicity of each zero, there is no math code involved really, but try to be clear nonetheless. So just list the zeros and their multiplicity. I suggested in class to have a little chart. So the zeros are 1, negative 2/3, and negative 3. And what we call the multiplicity is the exponent of the corresponding factor. So a multiplicity of 2 for negative 1 and positive 1 and negative 3, and a multiplicity of 1 for negative 2/3. And the first thing that I am going to do is to plot those zeros when I graph. So I've got 1, I've got negative 2/3, which is negative 0.6 roughly here, and for negative 3 right there. All right, so the end behaviors tells me that the polynomial is going to come from there and go up towards the negative infinity over there. Now, because negative 3 and 1 have a multiplicity of 2, which is even, the graph is going to bounce off the x-axis. So at some point it's going to turn around, go up, turn around, and here bounce off again, and then shoots for the positive infinity. So of course I'm going to get something more accurate with the calculator, and I'm going to show you some tricks to do so. So the first thing that you want to do with your calculator is to press y equal and to just enter the expression for this given to you for this polynomial, and then you're going to graph it. Now, to have a graph which resembles what you should have on paper, look at the graph and the dimensions of the graph, and I'm going to give this window the same dimensions. So the minimum value for x is roughly negative 5. You do not need to be accurate. The maximum for x is 3. The minimum for y is negative 5, and its maximum is roughly 4. So I graph, and I will have something more interesting. Now, what I am mostly missing here, it's this minimum right there and this maximum here. So what I'm going to do is that I'm going to press second traced to go to the calculate window, and I'm going to first look for the minimum. It's going to ask you two questions, left bound, right bound. So I'm going to go to the left of the point that I am looking for, press enter to validate. I'm going to the right and press enter to validate, and then somewhere in between for the guess, and then press enter, and here we go. I've got negative 1.7 and negative 3.8. Negative 1.7 is roughly here. Negative 3.8 is roughly here. So I will have a point here. Now, you may have noticed I could do the same thing for this maximum, but here is just to the right of the y-intercept, rather. So it's going to be enough. So the y-intercept is 1.8. So I had that here. And That's going to be enough in that particular case to graph something decent. Remember to do by little stroke, by first joining together the maximum and minimum. You can eventually use also, that's a possibility, the button trace. The button trace will make the cursor stick with the graph and will give you a series of coordinates. And that's pretty much it. Once you have something decent, then you can do longer stroke. Take your time of doing this, and you should have something like that, a little bit decent. Take your time. And here we go.